All right, so of course, hopefully you remember partial fractions and so on, right? Good. How do we integrate, right? So we should be able to integrate all these basic things here, right? I just want to go into a quick revision before we start partial. Differential equation. Right? So first thing first, we need to remember how to integrate. Add 1 to the power divided by the power. Integral of 1 on x is ln x. Integral of 1 on ax plus b is 1 on a ln ax plus b. Right? Integral of ax, sorry, e to the ax plus b is 1 on a, e to the x plus b, and so on. Right? You will see these are trigs here. The integral of sine minus cos. Integral of sine ax plus b is minus 1 on a cos ax plus b. Okay? So I want you to remember these little things here, right? There's an error to be multiplied, right? Should be dx here. The integral of cos is sine and all these here. Right. Some of the ones that you're going to see in differential equations are this one here, tan. The integral of tan is ln sec x. If you don't remember it, write it down now because you're going to use it. Right? The integral of tan is ln sec x plus b. Write it down, Anna. You don't remember that. Yeah, show it here. That's the integral of tan. Yeah. But write this down for now. Right? So you're going to need to remember the integral of tan, integral of sec. Right? Write down the integral of sec as well. Yeah, I think I use that one. One expression, you will see it. Right? So the integral of tan is ln sec x. The integral of sec is ln sec x plus tan x. We will need that. Of course, we know the integral of sec squared already, right? So you don't have to write out one. You should know that. Right? And then write the last 3 integrals down here. Oh, so it's temporary. Write these 3 here. All right, mine's over. Right, those there means the last 3. Okay. So the integral of f prime x on f of x is ln f prime by f of x to the n is f of x to the n plus 1 on n plus 1. Right? We're going to use those 5 integrals. After again. Huh? Yes, you are seeing. Oh. All right, so we're going to use these integrals now to solve differential equation. Right, well, nice and simple. Well, nice and easy. A little bit long for some, but nice and easy. Anybody sorry, yeah? So, differential equation 1 and 3. Let's sum through the do 1 and 3 together. Yeah. Huh? Oh, so you got differential? Okay. How it was easy?
Last question is about guidance. It was a The teacher had to write down both word.
Yeah. Someone else
Word and write down next set of.
second order.
Yeah.
Second order is very long. I need 2 words for that. All right, nice. So write a little smaller. I can do it. Ready? Right, so now let's just introduce it. Right, so what we're going to try now, we are going to try to solve differential equation. Right, so we have 2 types. Right, we have 2 types of differential equations that we're going to learn to solve. We are going to learn to solve the first type, let's call it A. We are going to learn to solve first order. Technically, you all did this already, right? You all did this in unit 1. You all remember solving in something like this. dy dx is equal to 2xy. Remember that? In unit 1, that's a first order. How you do it? Separate the variables, right? So in unit 1, we looked at solving first order. And one of the techniques that we did is we did separating the variables. All right. So we have first order, and you may have done simple second order. Right, so we have first order and second order, right? How to identify a first order? They generally look like this. dy dx, right? The highest differential is 1. Okay, and a second order, the highest differential is 2, right? But if you were to see this does not mean a second order, right? This just means you're squaring a dy dx. This is a degree of 2, right? So we are focusing on second order. First order, the highest power is dy dx. Second order, the highest power is d2y dx squared. So in a first order, right, we only use first differential. Here we use second differential. So our first order might look like this. F of x, sorry, dy dx is equal to p y plus some function, right? Let's call that q of x. Right? Here, a second order might look like this. A d2y dx squared plus b dy dx plus c by y is equal to some function. Right? So generally, first orders look like that, second order looks like that. How do we solve first order? Number 1. Right? Number 1 is the way that we did in unit 1, separation. Separation of variables. Right? That's what we did in unit 1. And in unit 2, we are going to use something called integrating factor. Right? So we're going to do separation of variables, integrating factor. Right? That's first order. This is not that long. Right? But here is really long. These are the very long ones. Right? And to solve second order, we're going a little bit longer. We're going to find something called a complementary function and a particular integral to obtain the general solution. This is and. Right, so to solve it or to get the general solution, these are the things that we're going to do. Huh? Well, I'll show you that later on. This is your complementary function and particular integral. Okay? So, yeah, so we're going to have to learn to obtain those things. Complementary function, particular integral. All right, so before we start second order, right? Before we start first order, sorry, we have to know when to use either technique, right? To use separation of variables, you'll recognize that the first order generally looks like this. Dy dx is equal to f of x by, let's say, g of y. So it looks like the product of two functions. See here? You have product of two functions here, right? So we have some to separate. To bring the y on this side, bring the x on this side, right? You'll hardly ever use this technique though. You'll more use the integrating factor in unit 2. How you know when to use the integrating factor? When the function looks like the one on top. If you could write the function in this form, dy dx by some constant by y is equal to a next function there, then what you have is something that you can use integrating factor for. Okay. Right, so let's make a note of that. To use first order, to know which technique to use, you have to figure out which form it is. All right. I'll show you this one in detail, but we're gonna practice a few of these first. All right. I think I have one in the past paper or two in the past papers like this. Right, but that's the older here. You're gonna more see them look like this. Yeah, Jada? All right, so let's focus on the first type, right? Let's focus on solving first order differential, right? All right, ready? So with the first example, you'll recognize that this is of the form dy dx is equal to f of x by g of y. So here we can use the separation of variable technique. Right, so let's separate the variables. So all I'm going to do is I'll bring the y on one side, I bring the x on one side. So I'll bring in y here. I'll get 1 on y dot dy is equal. I'll bring in the dx on this side, 2x dx. Now it's easy for us to integrate here with respect to y and here with respect to x. What's the integral of 1 on y? Ln y, right? What's the integral of 2x? X squared, right? And of course, we must have plus c. What is here? You'll recognize that we have two integrals, right? So there should be a constant here and a constant here, right? So you will recognize in these solutions, they only write one constant, right? And the reason is simple. If I were to put constant here, let's call it K1, and put a next constant here, K2. When I bring K1 across, and I will still get one constant. So technically, they only have one constant, right? So that's why you do put a constant here and here, right? Just put one constant alone. Okay. So sometimes you can watch it and you can separate the variables. Sometimes it will look a little more complicated like this, right? Suppose it looks something like this: 1 on x, dy dx. Online, you're okay here? Karina, but okay here with this one? All right, nice. Right. Sometimes it look like that. Right? When you watch questions like this, you might say, okay, well, can I multiply this and make it look like this? Oh, look at. If you like it, expand this out and make it look like that. No, that's too complicated, right? But if I were to bring this here, or bring this here, if I were to bring this here, it will look like this. Instead of multiply, it will be g of y over f of x. Correct? If I were to bring this here. Enter. Sure. If I were to bring it here and write 1 plus x, it will be dy dx is f of x on g of x. Or technically, g of y by f inverse x if you want. Right? So, how do we solve this? Well, we will do exactly what we did in the first one. We will separate variables, right? So I'll take 1 on sine, 1 minus sine squared, which is what? 1 minus sine squared is what? Cos squared, right? So instead of writing this, I'll just bring it across cos squared. So I'll get 1 over cos squared dot dy, and I'll bring it across the 1 on, I'll bring it across the 1 on x. So I'll get 1 over 1 plus x with respect to dx. I'll give it up. What's the integral of this? Oh, by the way, I forgot to mention something. The purpose of this, the purpose of solving it is to solve for y. So really and truly, I should have made y the subject of the formula here, right? So I left out that line. I should have made y the subject. Sometimes it look nice. Like this one, if I make y the subject, when they carry across ln, what you'll get? E, right? So I'll get y is equal to e to the x squared plus c. Right? So really and truly, I should have made y the subject of the formula. Right? When you move across ln, you'll get e to the x squared plus c. Are you okay with that? Right. Copy this down so we can finish up now. Adam. Huh? Which is this one? Right, yeah, so let's finish up that now. Integral of 1 cos squared dot dy 1. Ever was the integral of 1 cos squared? What's the integral of 1 cos squared? All right, brother, I'll make it easy for you. What's the integral of sec squared? Isn't that is sec squared? What's the integral of sec squared? Tan, right? That's all. So you write tan y equal to what's the integral of 1 over 1 plus x? Jude? What's the integral of 1 over 1 plus x? 1 is on x. 1 is on x. Close state. What's the differential of 1 plus x? So therefore, it's just simply ln of 1 plus x. That's okay? That's clear, remember? Right? Remember, when the numerator is the differential of the denominator, then this is ln, right? Yeah. Come on, go to the next one. Right, copy that. Let's go next one. So please remember this here we call this the general solution. Okay, this is a general solution. I'll show you how to get a particular solution. Okay, so like this here, next example, that is your general solution. So no matter what you put for x and y, this is the general solution. But if I give you a value for y and a value for x and you work it out, and you work out c, that's called a particular solution. So listen again, this here is a general solution. If you were to solve this, it'll always look like this. But if I give you conditions for x and y, you will get a particular value for c. When you write that value, that's called a particular solution. But this here is your general solution. This one here too. Online, are you okay there? Adam? John, are you okay there? Right, please, you all need to remember how to integrate. Right? Otherwise you'll check out again. Right, very good. Okay, this is all. All right, I'm gonna give you an easy one that I can most likely integrate, right? Okay, one that I can integrate. This one. Find a particular solution for this. Find a particular solution for that. Find a particular solution for this, please. Right? So after you get a general solution, you have to get your particular solution. Right, so we had to separate the variables, right? Okay, it's of the form what? It's of the form f of x by g of y, right? So we separating the variables and work it out. Okay, so what you do with the y? Bring the y on this side and bring the x on this side. And then integrate. Right, those who are online, they can just message what you get to see, right? Right, you have to messaging with it, but message what you get to see. Yeah. Right, so let's see what it come up with. Yeah. Right, so when you separate the variables, Andy, you bring in the y on this side. Right, so remember earlier, if you're integrating with respect to y, everything here must be y. And carry across the x here. So that will be 2x over 1 plus x squared. Okay? You'll see that? So everything with x have to stay here, everything in y have to stay here. What's the integral of this? What's the integral of 1 on y? Ln y. What's the integral of 2x on 1 plus x squared? Yeah. Integrate 1 over y of ln y. Oh, no. Remember, the y going, so you're dividing here by y and you're dividing here by y. So you're dividing here by y to cancel, you're dividing here by y. So 1 on y. No, no. Right, no, but when it is is y here. So when you bring it here, it'll be 1 on y. If you have 2 and you bring 2 across the equal sign, it becomes what? 1 on 2. So this is y and you bring it across, it becomes 1 on y. Right? And remember, this is 2 on 1, right? What's the integral of 2x on 1 plus x squared, Vera?
Plus x squared.
So it's ln 1 plus x squared plus 3. Right, but here's the problem. Right, one little problem I saw is that when you were trying to make y the subject, right? You're moving across ln, right? When you move ln across, it becomes what? E ln 1 plus x squared plus c. Okay? William? So when you move the ln here, it becomes e. Plus means what? Plus in the c means multiplied, right? Right? So it means multiplied by e to the c. That's okay? Yeah? So this here with the plus sign means e to the ln 1 plus x squared by e to the c. E of ln, they'll cancel up basically, and you'll get 1 plus x squared by e to the c. Then again, tell me. What will be minus of 3 by? Why you do that? No, remember the objective to make y the subject. So you would say you would bring that here. No, but you still have to make y the subject to get a general solution. Yeah. Start it out. Because that's a rule. If you can't just drop off ln like that, right? You have to make ln. You can only do that if you didn't have a plus c. If plus c wasn't there, you could drop the ln. But because you have a third term or second term on this side, you can't do that. Yeah. Right? Because remember, you can take logs or take ln if you have 2 terms, right? But the third term, you won't be able to do it like that. Yeah. No, but still, you can't drop ln third term. Yeah, ln on both sides, here and here alone. So that's when you do it. Time you solve is like this. 3 to the x is 4. You take ln on both sides. If you have a next value here, you can't do that. Right? Right, so you end up with y is equal to 1 plus x squared. Right, and you can write it like this: k by 1 plus x squared. But you will tell them that k is equal to e to the c. So it looks a little bit nicer. When you reach here now, you plug in when y is 2, x is 0. Right? So when y is 2, x is 0. So you'll get k by 1 plus 0. So you're going to get k is 2. So your final answer will look like this. Y is equal to 2, open brackets, 1 plus x squared. That's what your final answer will look like. Right? The reason I put it in this form is this is what they will do. Right? They will want you to write it in a form like this so it looks a little bit nicer. So you don't have the e to the c here. Okay? So you replace e to the c with k and then solve for c. Anybody got 2?
สุดว่าเกณฑ์ได้แล้วจะถึงไงวะ
วันเนี้ย
ไม่ได้ว่า
right? But if you get C as ln 2, then that's correct as well, right? Because watch, if you put ln 2 here, e to the ln 2 is 2, right? So if you got C as ln 2, that's correct. I just simplified it a little bit further. Right? You should get this for your final answer. Any questions online there? Right, and this is what I want to point out here. What I want to point out here is that remember when you're trying to get a general solution, you're trying to make y the subject of the formula. So in order to make a y, you're going to have to get rid of your ln, right? So when you carry the ln on this side, it becomes this. You're in the habit of writing it properly and breaking it up properly, right? Plus means multiply. So this here means e to the ln of this multiplied by e to the c. Right? And then we'll take off e to the c and result constant. Ready? Let's go again. Put this one up first. Yeah. Somebody have something. And we expanded. Yeah, if you want here. 2 plus 2x squared here if you want. But up to there. All right, let's go. So let's see if we can try this one here. This one a little bit different. They give you, how are we doing part one? Part A. How are you doing part A there? Part A is what? Andy, how are you doing part A? Yeah. How are we doing part A, Andy? Yeah, Andy. And the integration by parts, and the that before. So the first part is integration by parts, and it's supposed to help you with the next part. Supposed to. All right. Go ahead. Try this, please. Copy down. Try that, please. Right? Integration by parts, Andy. Which one are you going to differentiate here? Andy. Andy. Which one are you going to differentiate? X or E minus X? Which one? Differentiate. Okay, that's it. Let's do it up with old one, like 2006. 2006. Hey, let's try that pair. Excuse. Well, hurry up now, boy. Wrong man saying has not been. Oh yeah. So try to find the integral there, right? Differentiate the right thing, integrate the right thing, and work it out. And then solve below. Solve that there. Right, before we continue next week, please go about the integrate. Go about the integrate. Right, you need it. You need to be able to integrate properly. That's straightforward. Do you finish? Right, I want to take it off, right? And the question. On your phone? Oh yeah, copy down the whole thing. I want to take it off. Right, and try to solve B now. Of course, we need part A and B, right? Right, so here you'll pick u as x and v as e to the minus x. So du is 1, and how do we integrate this? 1 over the differential of minus x, which is minus 1, and then you write back e to the minus x. So it's the same as e to the minus x. That's okay? So it's 1 over the differential power. Okay? So therefore, the integral of x e to the minus x dot dx is equal to u by v x e to the minus x minus the integral of du by this. So that's 1 by minus e to the minus x dot dx. This minus sign I can put it on the outside, and it becomes a positive integral of e to the minus x dx. Yeah. And last part was the integral of e to the minus x. We did it already. And you get minus e to the minus x, and you write it plus c on the s. Okay, so the integral of this with respect to x is that. Okay. How is this going to help us with the second part now? The second part, the answer is solve. Yeah. The formula is ub minus du by. Oh, sorry, yeah. So it's sorry, no. What happened is that you will write this part. Right. Everything all right, bro? So it's this by this. So I'm missing a minus sign here. Right? And then du by d. So I have that right. Okay. You ready? Whole thing wrong. All right, so it looks something like that. Right, and then they asked us to solve, where I got this from, right? Then they want us to solve the equation e to the x dot dy dx is equal to x over sine 2y. What do we do? What we gonna do now? Separate the variables, right? So bring the sine 2y on this side and bring the e of x on this side together with the dx. So we'll end up with sine 2y dot dy is equal to x right. Can I put e to the x as x over e to the x dot dx. Right? So you bring across e to the x here, and you bring across sine 2y here. That's okay? Remember, this is underneath there. So when you bring up sine 2y, it becomes multiplied, right? So it's not 1 over sine 2y. Okay, and then we integrate here and integrate here. Right? Just pick one now. William, What's the integral of this? What's the integral of this? There's a reason we do all this, right? What's the integral of this? Take it out, no? You can't take out the function out of an integral sign. But what does if I bring it up? What will it be? It will be e to the, which is the same as the integral. That's it. Okay. Right? Koi, okay with that? So x on e to the x is the same as the original integral we found here. Yeah. Right? What's the integral of sine 2y? Yeah. And this is the non-linear one that you might see on your exam. Right? But the only reason you all struggling is you all don't remember this little thing. For homework, you'll go home, you'll do it, and you'll be ready for next week. Right? We almost done. Adam, what's the integral of sine 2y? What's the integral of sine 2y? Minus a half cos 2y. Thank you. Right? And what's the integral of this here, Andy? What? What? What's the integral of this? I'm down the bookmark now. What's the integral of this? Andy, you wasn't listening, I just showed them here. So the integral of this is this here. So that's minus x e to the minus x minus e to the minus x plus 3. Huh? No. Right, this is looking kind of bad, but we still have to make y the subject, right? Ideally, you have to make y the subject. So multiply everything by minus 2, and you will get cos 2y is equal to 2x e to the minus x plus 2 e to the minus x plus 2c. No, sorry. Minus 2c. Which one? It don't matter, but in terms of how we simplify, yes. So I'll say yes. Right? And then you can carry across cos and carry across y. You got more to it, right? Yeah, I think I gave you y is pi and 4 something like that. No. Find that for me. Plug in y is sine pi and 4 and x is 0. So this is 0, this is 0, right? Oh, sorry. This is 2. Right? Plug it in, please. Plug in y is pi on 4 and x is 0. Tell me what you get for c, please. Plug in y is pi on 4, x is 0, and what you get for c. This will be 0, this will be 2, and pi on 2 plus 90 is also 0. Right? So I got minus, I have 1. Yeah, who got 1? Who else got 1? Yeah. You got 1? Here's 1. So what we did here is first order, the ones I will not see in your exam. Right? So these are the ones I only have like 1 or 2 questions on. Right? Right? This is supposed to be easy, but you also do not remember how to integrate, how to be easy. Please go over that. Please go over integration for next week, please. Right? Andy? Over integration for next week, please. Alright, so you have to be able to integrate. Next week, we will do first order and do all the past papers on it. And the week after, second order will take a little while.